For this exercise, we're told to solve by graphing and then also by substitution or addition or elimination. I'll leave the solving by graphing to you, and we'll work on solving this by either substitution or elimination or addition. Here's my system of equations. If we want to solve by elimination or addition, and I believe I will because notice the x's are lined up, the y's are lined up, and the constants are lined up, I want to multiply one or both equations so that the coefficients of the x's are opposites of each other or the coefficients of the y's. Now notice if I multiply the first equation by 4, this coefficient is negative 4, this coefficient is 4, and I do have opposites of each other. So let's do that. I'm taking the first equation and I'm multiplying through by 4. So 4 times 2x is 8x minus 4y. Very, very common mistake, so be careful. Don't forget to multiply this number by 4. So that's negative 4, and I'll rewrite my second equation. That's 5x plus 4y is equal to 17. And now look what happens. I can add the two equations, 8x and 5x, that's 13x. The y's subtract out, and I have 17 minus 4, 13. I can now solve for x. I'll divide both sides by the coefficient of x, which is 13, and I have x is 1. So it looks like we have a single ordered pair solution. How do I find the corresponding y value? I let x be 1 in any of the equations containing two variables here. I'll just choose an equation. I'll choose the first equation. Let x be 1. And we'll solve for y. So that's 2 minus y is negative 1, or negative y is negative 1 minus 2, or negative 3, and then I'll divide both sides by the coefficient of y, and I'll have y is 3. So the corresponding y value is 3. How can you check? Make sure this is an ordered pair solution of this equation and also this equation. If so, it is an ordered pair solution of the system. And by the way, this should be the point of intersection when you solve graphically.